This is really interesting, and I want to walk through it. So let me set the stage here of what we're looking at. The top image is the temperature in the mealworm farm over the last week. So you can see really steady across the top here. It's really, really good there, nice and steady. That's what you want. This drop here, it's a sensor push thing. Every now and then those sensors don't register, and it's like a negative, awful, terrible number. So it's a data point we can get rid of. This dip here was me yesterday. So I ran the exhaust fan and drove that temperature down. The goal is to get some more oxygen in the room because I was in there working. We'll talk about that at some point here as well. But otherwise, really consistent temperatures here, right? Like this is what you want to see for mealworms so that you get better results from your consistent temperatures. On the bottom here, this is a temperature sensor push sensor that is out in the front part of the building that's not insulated. So this is ambient temperature. Ambient in the sense that if it's a really sunny day, it's going to be a few degrees warmer, and it'll maintain a little bit of that temperature into the evening as it drops. But this is the air that gets pulled into the insect room whenever the exhaust fan turns on once the temperature gets too high. So right now I have a sensor hooked up to the exhaust fan that once it reaches, I want to say it's 80 degrees in that section of the room. Once it reaches 80 degrees from that sensor, it will turn on and run until it gets back down to 76 at that sensor. And so what that's doing is two things. One, it's keeping the temperature in that range, right, which we can see here. It's keeping the temperature in that range. And when it does pull in that air, it's pulling in this ambient temperature air at the bottom, this air here. So what's interesting, and same issue here with the data at the bottom. This guy right there is since it happened on two sensors, now my thought is that's probably the gateway. So they're connected to a gateway that then uploads this to the internet so I can see it in real time from anywhere using my phone. Yeah, I'll think about that. But anyway, those two data points we can get rid of. They're not impactful. It's not like the temperature suddenly dipped below to negative temperature, negative 13.8 degrees Fahrenheit. It didn't happen. So what's really cool here is the other piece of info that's not shown here is that I don't have the heat turned on. So I have electric heat in that room through that HVAC unit that I have, and I have not turned it on. And so all of this temperature control here, where the exhaust fan turns on and ventilates and then pulls in this 38 to 51 degree temperature air, it's pulling in that cold air, and then the mealworms themselves are keeping that temperature up and driving that temperature up. That's really interesting. They're generating heat, and now the colony is big enough. Last winter, I didn't experience this. Last winter, I used a 220 volt electric heater. My electric bill was $220 plus a month, I believe. It was crazy. But I was prepared for that this winter. And what's interesting is I have not had to turn the heat on yet. And so the mealworm colony is essentially full in that room. I could probably fit, I say full, but I can probably fit another 20 to 40 stacks into that room and generate even more heat. So this is pretty interesting. I don't know how this is going to pan out long term, because at some point we'll hit a threshold where this outdoor ambient temperature down here, where it is so cold that when it pulls in that heat, or when it pulls in the air, it's going to dip that temperature down low enough that I don't know how long it's going to take for those mealworms to recover that temperature. And so I may, like at that point, we'll hit a threshold where I'll want to supplement with heat to maintain this good consistent number here up in the upper 70s. What's really interesting about right now is even with the dips down to 38, the temperature recovery is pretty quick, right? So you're seeing these real jagged up and down. Woo, 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 woo. It's raising that temperature up pretty quickly. I was not expecting this. I was not expecting the mealworms to be able to generate this much heat. I think it's okay. Like long term, what I think will continue to happen is as the colony expands, which is one of my primary goals right now, as I build that building out and then increase the colony size, they're going to generate additional heat. In the wintertime, that's okay, because in the wintertime, I can just pull in external air just using an exhaust fan. In the summer, that's not going to be good. That's going to be a lot of air conditioning. And so I need to probably start thinking about more efficient ways other than an electric air conditioning unit to get my temperatures, keep my temperatures under control. So if anybody has any thoughts on that, that's a thing I'll need to worry about in June, May, June-ish, potentially sooner depending on how much heat they're generating. But in the wintertime, I'm projecting lower costs, but we'll just have to wait and see. It's a totally different HVAC unit. Last year was electric 220 volt. This year it's a standard HVAC. It is an electric unit, but the colony is much, much bigger than it was last year. So we'll just have to see how this pans out. But this is some pretty interesting data. As your colony expands, those mealworms are generating heat. And that's something to keep track of and to think about as the seasons continue to change a little bit.